Welcome to qnawire.
Okay, now I don't have this model for pentanoic acid, but I can draw it. This is what pentanoic acid looks like. And the important thing to recognize here is the number of hydrogens that we have on each of these carbons. Recall there are 2 hydrogens on each of these points that have 2 lines coming from them. If you're not super familiar with organic chemistry, what we're basically doing is for any point, we're making sure there are 1, 2, 3, 4 bonds coming from it. And anytime there aren't 4 bonds, that implies that there are some hidden bonds to hydrogen, right? So, for example, here we see 1, 2 bonds written explicitly, which implies that there are 3, 4, 4 total bonds, and therefore 2 bonds to hydrogen. So for this terminal carbon here, there must be 1, 2, 3 hydrogens to total 4. Okay, so from this, we can determine what the empirical formula is for pentanoic acid. And so we'll count the carbons. I see 1, 2, 3, 4, 5 carbons. So let's call that C5. Okay. Typically, we would do the H's next. So I see 3, total of 5, total of 7, total of 9, and then 1 on the OH for a total of 10. So C5H10, and 2 oxygens, O2. Okay, so this is our formula for pentanoic acid, and this is what we need to write a balanced chemical equation that shows the formation of pentanoic acid. And so we're going to have carbon, solid, plus oxygen, which is O2. It's a gas. Let's leave a little room for coefficients here. Plus H2, it's a gas, and we want this to go to C5H10O2. Great, so now we just need to figure out, I did not write H10, I wrote H2. Let's fix that real quick. H10. Cool. So let's just start from the left. It doesn't really matter where we start. It's kind of arbitrary. To me, it looks like I can just say 5 carbon, right? If I put a 5 here, I'm going to have 5 carbons on the left side and 5 carbons on the right. That looks good. Let's move on to the oxygens. Well, it looks like I've got 2 oxygens on the right, and this is O2, recall, so that a single O2 will give us the 2 oxygen atoms that we need. On the left here, I've got H2 molecule. I've got 10 hydrogens needed. So how many H2s would give me 10 hydrogen atoms? 5 H2s would give me 10 hydrogen atoms, right? 5 times 2 equals 10. That's what I'm basing that off of. Similarly, this is 1 times 2 equals 2. And here we just have 5 times 1 to equal 5, right? Because if there's no number there, we're assuming that it's a 1. And that should be it.